Hi, welcome to today's pre-calculus lesson on chapter 1.2, which is titled Graphs of Functions. Go ahead and write your first and last name and what period you're in. All right, for the first slide, we're going to be talking about the graphs of functions. So the graph of a function, f, is the collection of all the ordered pairs x and f of x such that x is the domain of f. So we're going to find the domain in the range of a function from its graph. So I have two graphs right here. I have this one on the left and I have this one on the right. So the one on the left, this yellow highlighted part, the domain, which I'm just going to abbreviate with D, is whenever x is greater than or equal to 2. So if you follow along the x-axis, it starts at positive 2 and the point is filled in. So the x is greater than or equal to 2 because as you keep going x, you're going to get all the numbers greater than or equal to 2. The range is for all the numbers y greater than or equal to 0. So here's the y-axis. It starts at 0 and going up. That point is filled in. So it's everything 0 and greater for that one. For this second graph, the domain is going to be when x is less than or equal to negative rad 2 or when x is greater than or equal to rad 2. Because there's two parts of this graph. This part on the left, or going to the left, starts at negative rad 2, and they tell you that in the point, and goes all the way to negative infinity this way, so it's less than or equal to negative rad 2. And the right part of the graph starts at positive rad 2 and goes on to positive infinity, so it's greater than or equal to rad 2. The range for this graph, here's the y-axis, it starts at 0 and everything greater than, so y, or the range, will be when y is greater than or equal to 0. Then we're going to talk about something called the vertical line test. For the vertical line test, you're going to take a pencil. I have a pen, but you can take your pencil, and you're going to start at the left side of a function and move across. And if your pencil only touches the graph at one point, you're going to say, yes, it's a function. If it touches 2 or more, you're going to say, no, it's not a function. Okay, so a set of points in a coordinate plane is the graph of y as a function of x, if and only if no vertical line intersects the graph at more than one point. So this first graph, here's a vertical line and it's touching at 2 points, so you say it's not a function. The second graph is this line right here. And here's the vertical line right here. It's only touching at 1 point, so you say yes, it is a function. The third graph is a parabola. And here's the vertical line. It's only touching at 1 point, and if you keep moving it, it's only going to touch at 1 point. So yes, it is a function. And the fourth graph is a parabola, but it's turned on its side. And here's the vertical line, so it's touching at 1, 2 points. So you say no, it is not a function. All right. Now we're going to talk about when a graph has a minimum, a maximum, is increasing, decreasing, and where it's constant. Okay, so this graph is increasing from negative infinity all the way up to this point, and then it starts decreasing, and then it starts increasing again. So there's two parts for increasing. So the first part increasing is from here and backwards, so anytime x is less than 0. And from this part right here, which is what, 4/3. So when x is greater than 4/3. Okay. Where is it decreasing? It's decreasing all the points between these two guys. So when x is between 0 and 4/3. All right. Is this graph ever constant? This graph is not constant. So constant would be like a straight horizontal line. So nowhere is this graph constant, but you could have a graph that has a part that is constant. All right, so let's talk about the relative minimum of this graph. So you see minimums when you have parabolas and you just have one minimum or you have one maximum. But on here, you have a relative minimum because you have a minimum and a maximum. So here's the minimum right here, this little red point, and that red point is at the y value, which is negative 32/27, and I just got it from the label on the graph. And the relative maximum is this green point up here, and it doesn't have a label on it because it's the origin. So the origin is 0, 0. So you say the relative maximum is at 0, which is the y value, also happens to be the x value, but they just want the y one, the y value. Okay? All right, so let's talk about symmetry. Symmetry just means one side's going to be the same as the other side, so kind of like a reflection. And so it says a graph has symmetry with respect to the y-axis if, when the point xy is on the graph, so is the point negative xy. Okay, so what does that mean? So you have the y-axis right here, and on the right side you can find a point. For instance, we could find this point 6, 5, and we go over to the same spot on the other side of the graph, and it's negative 6, 5. So the x value is the opposite, the y value is the same. That's why it says negative x, positive y. So the y stays the same, the x is the opposite. Or you could go from left to right. I went from right to left. Okay, so on this one it's negative 2, negative 3, and the point over on this side is positive 2, negative 3. So a function whose graph is symmetric with respect to this y-axis is going to be called an even function. Okay? All right. Now here's a different kind of symmetry. It says a graph has symmetry with respect to the origin. Remember, the origin is the center or the 0, 0 spot on a coordinate plane. And if whenever any point xy is on the graph, so it also has a point negative x, negative y. For instance, the two red ones. So this red point up here is 2, 8, and this red point down here is negative 2, negative 8. So this one is called an odd function. 1, 1, negative 1, negative 1. So anywhere you can find positive, positive, you would also get negative, negative. Okay? So the signs are opposite. It would work in the other two quadrants as well. So in quadrant 1 over here, or quadrant 2 over here, and quadrant 4. All right. A graph has symmetry with respect to the x-axis. So going this direction, here's the x-axis, and this time the point xy is going to switch to x and the opposite y, so or negative y. So this red point right here is at 4, 2, and its symmetry over the x-axis is going to be 4, negative 2. So the same, just over the x-axis. The graph of a non-zero function cannot be symmetric with respect to the x-axis because why? It would not pass the vertical line test. Okay? So you say it's not symmetric, and you can just say it doesn't pass the vertical line test. All right. I need to make this a little bigger. Let's see if I can slide this open. Nope. Okay. So even, odd, or neither. There it goes. All right. Determine if the functions are even, odd, or neither. So in order for a function to be even, if you substitute in negative x, you're going to get out whatever function you started with. If you plug in negative x and you get out the opposite of that function, you're going to say that it's odd. So I have 3 examples here. The f of x, the g of x, and the h of x. So let's do f of x first. We're going to plug in negative x. So everywhere we see x here and here, we plug in negative x, and then we simplify. So negative x to the 5th power, I'm going to pull out that negative 1 so that, because when you multiply a negative and to the 5th power 5 times, so you multiply negative x times negative x times negative x times negative x times negative x, you would get negative x to the 5th power. So I pull that negative 1 out, multiply the negative 1 times the 8, and I get negative 8x. And then 7 times negative x is negative 7x. And so the answer would be negative 8x to the 5th minus 7x. If you compare that back to the original function, you're going to notice that the signs are just opposite. It's negative x. You'd have a negative sign here and a negative sign here. So it's the negative of the f of x, which means that the function is odd. That's the second one we saw up here. Okay. Now let's try the h. So we're going to plug in negative x here and negative x here. Now what happens when you take a negative number to the 4th power? You actually end up with an even or a positive number. So we're going to leave it as x to the 4th. And when you multiply negative 21 times negative x, you get positive 21x. Add the 6. Okay, so let's see. We end up with 4x to the 4th plus 21x plus 6, which is almost this, but notice the sign's different. Here it's negative 21, here it's positive 21. So they aren't equal and they aren't opposite. So you say neither or neither. Depends on how you say it. All right, now let's try g of x. So we have negative 5x squared plus 13. So the only spot we have to plug in negative x is right here on this one. So we've got negative x squared, which becomes positive, and negative 5x squared makes it the same as our original g of x. So we're going to say that it's an even function because it turns out to be the original answer. All right. Next slide. This is called graphing piecewise functions. So for this one, we want to look and see, okay, we've got 2 parts to this graph. So this is the graph when x is less than or equal to 2. And this is what the graph is going to be when x is greater than 2. So for this one, I just picked some values. All right. So for less than or equal to 2, I started with 2. And then I went less than. So 1, 0, and negative 1. If I plug in a 2, 2 minus 2 is 0. 0 squared is 0. Plug in a 1. 1 minus 2 is negative 1. Negative 1 squared is 1. And so on. So then I just graphed a couple points. So 2 zeros right here. 1 1's right here. 0 4's right here. Negative 1 9 is right here. So it's this part of the parabola. Okay. Then for x is greater than 2, I plugged in numbers that were 2 or greater. Well, 2 technically doesn't count, and that's why I left it as an open point. So notice this one's filled in because that's where it has the equal part, and this one is left open because that's where it does not have the equal part. So I picked 2, 3, 4, and 5, plugged them into the function, got out my values so I could plot some points. So I have one at 2, 3, one at 3, 4, 4, 5. You're going to see it's going up, it's going to make this line right here. Okay? So this is a piecewise function because it has values going less than or equal to 2 and values going greater than 2. All right. All right, let's try one more of those. This one has 3 parts. So when x is less than negative 3, it's this much, or it's this function. If it's between negative 3 and positive 3, it's 2. And if it's greater than 3, it's 2/3 x. So this one in the middle is constant. That's this little line right here. And it's always 2. So if you fill in your t-chart, it's always 2. For this t-chart, you plug in values that are less than 3. And for this t-chart, you plug in values that are greater than 3. And you graph each of those parts separately in different pieces. That's why it's called piecewise. All right.